Do you feel the vibes?
Okay, so exponential and logarithmic equations. We're actually only going to do exponential equations today. So an exponential equation is an equation that contains a variable, which is an exponent, right? Or an exponent, which is a variable, right? Now, you can have exponential equations in one of these two forms, right? So let's take a look. This case here has a variable exponent only on one side of the equation. This case here has a variable exponent on both sides of the equation. And each of them are separate cases. So what we're going to do is we're actually going to start with that second type, where you have a variable exponent on both sides of the equation. When you do that, what you want to do is you want to make the bases on both sides identical to each other, right? And then after you rewrite it so that the bases are equal, then the exponents are also equal to each other, right? So why don't we take a couple of examples? So take a look at this one. I have one base of 4. I have one base of 16. Now the thing is, I want to make these two the same base, right? So 16, right, is what? 4 squared, right? Okay, so here's what I can do. This one, I can just leave it the way it is equal to, and then just the 16 can be replaced with 4 squared, right? Is anybody here 16 years old? I mean, I know a lot of you guys are, right? So if somebody asks you, how old are you? You can either say, I'm 16, or you could say, I'm 4 squared, right? They're the same thing. That's why I can replace the 16 with 4 squared. And then to the power of x minus 3 like this, right? So now that the bases are equal, you can just set the exponents equal to each other. So you can say x plus 2 is equal to 2 times x minus 3. X plus 2 is 2x minus 6. X is 8. Okay, now, back in the day when we were graphing exponential functions, what was the domain of exponential functions? All real numbers. Because the domain is all real numbers, we don't have to deal with extraneous solutions, right? Okay, so this one, I have a 36 and a 6. So what do you think? We can write the 36 as what? 6 squared to the power of x plus 1 is equal to 6 to the power of x plus 6. Now, watch the language here. We don't want to say you cancel out the bases or the bases go away, because that doesn't ever happen. Instead, if the two sides are equal, we say the exponents are also equal to each other. So 2x plus 2 is equal to x plus 6. X is 4. Okay, here, okay, no, because we just came from bonus and you already went to get your bag and everything, so we're here. Okay, so here we go. I have a 9 and a 27. Now, the 27 can't be written in terms of a 9. However, both bases can be written in terms of a 3. So I can make this 3 squared and that 3 cubed. So now, when the bases are the same, so are the exponents. So 2x plus 4, 3x minus 9. X equals how much? 13? 13. 13. Okay, so this one, what do you think? 5 squared equal to 5 cubed. So 2x plus 2 is equal to 6x. 2 equals 4x, x equals a half, right? And yes, they can be fractions, they can be negatives, whatever, okay? There's no restriction. Okay, now let's go back up here. Oh, actually, no, let's not go back up there. Let's continue. Okay, this one. So take a look. I have 1 over 3 to the n, 1 over 81 to the 2/3. Notice, we now have fractions. Notice this and this have the same form in the sense that it's 1 over a number, right? So 1 over 3, I mean, that's as simplified as you can make it. However, 1 over 81 is 1 over 3 to the 4, right? And then to the power of 2/3. So now n is 4 times 2/3, so 8 over 3. Okay. This is a different situation because although here you've got 1 over a number, here you just have an integer. So the 1 over 2, right, to the power of c is as simple as it can get. However, this one, we need to change it, right? Actually, you know what? I'm not gonna, hang on. I'm gonna do it a different way. So do you see how both of them can be written as a base of, with a base of 2? So the 64, for example, is 2 to the 6 times, 1/2. How can I write the 1/2 as 2 to the power of something? 2 to the power of -1 times c. So when you have a situation like this where you have a whole number and 1 over something, you're usually going to end up with one negative exponent to make them equal, all right? To get them into equal footing. So negative c is equal to 6 times 1/2. C is -3. Okay, now let's go up here. If there is a variable exponent only on one side of the equation, we have to do what we call taking the logarithm of both sides. And then when you do that, the base of the log should equal the base of the power. And obviously we're going to use ln for e. Okay, so let's take a look here. 4 to the power of x is equal to 13. So here we only have one side with an exponent, right? I need to take the logarithm of both sides. This is the one where, this is where the base is, and the base is how much? 4. So I say log base 4 to the x, is equal to log base 4, 13. Okay? It has to be log base 4 because that's what the base is. And you have to do it to both sides. Remember, you can't just do one thing to one side of an equation, right? You can't just add 3. You got to do +3, +3. Same thing, log 4, log 4. So now, what do I get on this side? We just did that on the whiteboards. What do I get? X equals log base 4, 13. And now, if let's say you're taking a test where there is no calculator available, this is actually a perfectly acceptable answer. If not, you would plug it into your calculator and you would get, whatever in decimals. Cool? Okay. So this one, I need to take log, but what log? What kind of log? ln, because it's a base of e, right? So ln e to the 2x plus 1 is equal to ln of 8. What do I get on the left side? 2x plus 1 is equal to ln of 8. Now what? Minus 1. Okay, so here I get 2x is equal to ln of 8 minus 1. Okay, can you combine the 8 and the 1? No, because it's ln of 8 minus 1, right? It's not ln of 7. Now what do? Divide by 2, divide by 2. Okay, why don't you take out your calculators? Let's plug this in. So x is ln of 8 minus 1 all over 2. You got it? Okay. Okay, so when you plug it in, right, like this one, make sure, right, before you even copy down your answer, this is what it shows. ln of 8 minus 1 over 2. So that should be 0.5397. Okay. Usually, yeah. Okay, what about the next one? What kind of log are we going to take on both sides? Log base 3. So log base 3, 3 to the x, log base 3 of 7. What do I get on this side? Right? Equals log base 3 of 7. Okay, and then if you would like, you can plug it in. If not, not. Okay. All right, what about this one? ln of both sides. Do not just do it to one side. You have to be like equal opportunity here, right? Everybody gets the same thing. You can't leave anybody out, okay? So what do I get on the left side now? 4 minus 3x is equal to ln of 6. I'm going to subtract 4. So negative 3x is ln of 6 minus 4, and that's not the same as ln of 2. X equals ln of 6 minus 4 over negative 3. Cool? 0.736. So let's see. Another way you can do it is you can like get the fraction, and then you have ln of 6 minus 4 negative 3. 0.736. Is that what you got? Is that what you were saying? Yeah. 0.7361. All right. Isn't that cool? Yeah. Okay. So that's where we stop today. And your homework is the worksheet. Okay.
Press start.